Alright, in this video, let's try to look at the nth roots of unity. So before we go to the nth roots of unity, let's try to have the cube roots of unity first. So the cube roots of unity means z cubed is equal to 1, or you have there z cubed minus 1 is equal to 0. So what are we going to do is to look at the factors. Look at the factors of this and find the values of z that will satisfy this equation. And after this, what we're going to do is to look at the properties of the cube roots of unity. Now, so for example, here we know that the factors of that is z minus 1 times the z squared plus the z plus the 1 and equal to 0. So therefore the first root, the z1 is equal to 1, while the second root here we can use the quadratic formula. Z is equal to the negative b, that's negative 1, plus or minus the square root of the b squared, 1 minus 4, times the a is 1, times the c is also equal to 1, divided by your 2a. 2 times 1. So let's simplify that. It will give us the z, which is equal to negative 1 over 2, plus or minus, this is 1 minus 4, this is 4 here, so square root of negative square root of 3 over 2. But what is that equal to? This one is z is equal to, this is negative 3i squared, so this negative 1/2 plus or minus I square root of 3 over 2. So there are three roots. The first root is z sub 1 is equal to 1. The second root is the z is equal to negative 1/2 plus I square root of 3 over 2, while the other root is negative 1/2 minus I square root of 3 over 2. Now, let's try to draw this one in our Cartesian plane, in our Argand diagram, and after which, let's try to get the properties. So, for example, this is our unit circle. Alright, if that is our unit circle, the first one is z is equal to 1. Let me draw that one. Z is equal to 1 here. So that's equal to 1. And the other one is negative 1/2, that may be somewhere there, and square root of 3 over 2, maybe there. Alright? So this is your z2, which is, let me just write it here, I don't know if you can see, yes, which is equal to negative 1/2 plus the square root of 3 over 2. And the other one is actually the conjugate. As you can see in this diagram, the other one is the conjugate of that. So if this is negative 1/2, the other one is negative, that is your z3, z sub 3, that is negative 1/2 minus the square root of 3 over 2 I, by the way, I forgot to put there the I. So these are the three roots of the cube roots of unity, or z cubed is equal to 1. Now, this cube root here has some special property. If you let this one, for example, if I will let this, the z2 as my omega, okay, and let's try to explore the omega squared, okay. So let's try to look at the omega squared. So omega squared is the square of that. So let's just try to find that. So I will the space is not that enough, but let me just try to write it here. Okay. If I want, let's say I want to square this one, and what will happen? What will happen for that? So when you square that, this is going to be negative 1/2 squared, that's going to be 1/4. Then this 2 times negative 1/2 times this one. So 2 times negative half is negative 1, plus times the square root of 3 over 2i. That will give me negative square root of 3 over 2i. And the square of that, so square of I squared is negative 1, so that is negative square root of 3 over 2, that is actually 3 over 4, like that. And look at that one. That's equal to what? That's equal to 1/4 minus 3/4. That's equal to 1/2 negative. And this is minus the square root of 3 over 2 times I. But look at that. What is this one? That is actually that z sub 3. Okay? So meaning, if you take the square of your omega, you will actually take the roots of the third root, which is actually omega raised to 3, like that. Okay? So again, if you have there, omega squared, omega squared. So the root 3 is actually equal to omega squared. So let's try to simplify it further, or let's explore this property. One moment, let me just get a paper. Oh, here. Okay, I have one more paper here. So again, if I let my z1 is equal to 1, it turns out that my z2, if I will let it as my omega, it turns out that my root 3 becomes omega squared. Now, I'm a bit interested that, what about if I will take, again, let me just write it here. The omega that I left is this one plus the square root of 3 over 2i. And the omega squared, the result after squaring it, becomes your z2, which is minus square root of 3 over 2i, like that. What about if I want to find omega cubed? I'm just trying to explore it. So omega cubed is this one, negative half, plus square root of 3 2i, then times this one here, negative half, minus the square root of 3 2i. Now, this is a very, very interesting phenomenon, that this and this, as you can see, there is plus there is minus over there. So meaning this one is actually equal to this times that is 1 over 4. And then this one is I there is I squared. Alright, there is I squared. So what is it? That's negative 1. And then this one is what's going on. This is actually 3 over 4. Alright? 3 over 4. And then you have there, that's it. This is now negative. And that is I squared. But what is that? What is that one? So that is 1 over 4 plus I squared is negative 1, 3 over 4, which actually will give you 1. And look at that. So you have there omega cubed. Omega cubed becomes actually equal to 1. So meaning, when you go back here, when you look at this pattern here on the circle, if that is your omega, you square the omega, you go there. Well, that's omega squared. When you take the omega cube, it will go there. Okay? Therefore, if I say omega to the 4th, it will go there. Right? Omega to the 5th, it will go here. Omega to the 6th, omega to the 7th. So basically, it just keeps on rotating. So what am I trying to say was that if I have now, for example, the omega to the 4th. So that omega to the 4th is equal to omega to the cube times omega. But what is omega to the cube? Omega to the cube is 1. 1 times omega, then that's equal to omega. And if you have the omega to the 5th, this one will give you omega to the cube times omega squared. this will give you 1 times omega squared, which will give you omega squared. See? So, meaning, if omega to the 5th, omega cube is here, omega to the 4th is there, omega to the 5th will go here in that omega squared. Okay? So, let's continue this pattern because it looks interesting. Omega to the 6 is what? Omega to the 6 is omega cube times omega cube. That's equal to 1 times 1 equals 1. Okay? So it just keeps on rotating around that unit circle. But what is something interesting here is this one. Look at this property. What we have seen is that 1 times the omega times the omega squared. We know that it's omega cubed. So therefore it becomes equal to 1. Okay? And by looking into this, we can say that omega squared is equal to 1 over omega, or omega is equal to 1 over omega squared, which is a very, very wonderful phenomenon. Okay? Now, what about if I will add, if for example I will add omega plus omega squared plus 1? What would it be? Okay? So, let's try to look at it. So when you add this, okay, I'll just put it here. This is your omega. This is your omega squared. When you try to add the negative half plus negative half is negative 1. You added with 1 there, that's 0. When you add this square root of 3 over 2i plus negative square root of 3 over 2i here, when you sum them up, that's also equal to 0. So therefore it shows that 1 plus omega squared is actually equal to 0. Alright, and you can infer from here that you can just play with this property here. So what you can say is that 1 plus omega is negative omega squared. Alright, or 1 plus omega squared is equal to negative of your omega. Okay? Or we can say that omega plus omega squared is equal to negative 1. So you can take all of these properties. Alright? Now, why is this important? In your examination, you will be asked, for example, to prove something like this. So this one is one of the questions in your exam, and it shows that prove that for all integers k, 1 plus omega to the k plus omega to the 2k is equal to 3, or 0 when k is an integer multiple of 3. Okay, so this is just a sample question. But before we go into this one, let's just try to complete this property. Here's property of the cubes of unity. Now, so this is now the reciprocal property. Okay, I think I would rather write it down. Okay, so what are the properties? Again, if you have z cubed minus 1 is equal to 0, and if you let our 1z is equal to omega, the z2 becomes your omega squared, and the z1 is omega. I misspoke. The z1 is 1, the z2 is omega. It will turn out that the z3 is omega cubed, and then we have said that 1 plus omega squared is equal to 0, and we have said that 1 times omega squared is equal to 1. And from here we can get a reciprocal that omega times omega squared is equal to 1. So this will give you two properties, that omega squared is equal to 1 over the omega, and the omega is equal to 1 over the omega squared. Please don't forget that this is not that algebra. algebra thing, this is actually complex numbers, that omega is a set of complex numbers. Omega is a root, okay, a root of unity. And then, so another property that we can say is that if for example you have the let's say, okay, never mind that property then. Okay, wait. So the z squared plus z, I think this is important that you need to know. The z squared plus z plus 1, that's the factor of z cubed minus 1, right? We said a while ago that the root of this, the roots is equal to omega or omega squared. Now, suppose that we have a new functions wherein the roots of the new one is negative omega and negative omega squared. Then that one, okay, that one when you plug in here, well, because these are roots, when you plug it in there, so this will be the roots of the equation z squared minus z plus 1 is equal to 0. So meaning when you plug in this negative omega here, okay, there, so this becomes omega squared minus omega plus 1, which is actually this one. So meaning when you find the roots of this, you will get this new, you will get this negative omega squared. Okay, so it means that, what does it mean? What am I trying to say is that the z cube is equal to negative 1. The z cube equals negative 1 has the roots, it has the roots of, wait, it's not visible in the camera, that the z cube equals negative 1 has the roots of negative 1, negative omega, and the negative omega squared. Okay, so that is the end of this video about cube roots of unity. In the next video, we're going to have examples of roots of unity or nth roots of unity. Thank you.